Hello guys, in this video we're going to write a preorder labeling of the binary tree with Haskell. So we have this binary tree definition, this data type, this example of binary tree, and subtypes. Some new types: total mean total number of the nodes in the tree. Count before mean how many nodes we count before we come to this node, and position mean the label of the node. So, and we want to label our tree in preorder. Preorder means that when we have the tree, at first we take the node and put it to the left. And then they take left subtree and right subtree. We take left subtree first, take it root and put it again at the left, and so on and so on. So let's define the type signature at first. Preorder function. The type signature will be we do not take a binary tree and produce a list. We take a binary tree and produce a new binary tree. So this means that we need at first take some count before. We need to provide this as an initial start argument. How many nodes we count before we come to this node. And the next thing we need are we need our battery with type A, and the next thing we need to return a result, and result will be a pair which contain a total number of nodes in this battery and the battery, but with a new type, which is the pair of our type A and of position. So I think this is correct definition. And let's start writing our function from the simplest case. Then we have an empty tree. I just pattern match it, and no matter what the count before, if we have an empty tree, then we return an empty tree, and the total number of nodes inside of this tree is 0. Okay. Next, if we have some tree here which we constructed with a node which contain A and left and right subtree, and is the count before. This means that in n we put the number of nodes that we count before this node. Let's count from the left side of it. And of course we need to, in this case, we need to construct a new node. And we constructed with a node type constructor, and as a value we produce a pair which contain this A and exactly this N. So n plus 1, I think. N plus 1. And So if we have count before 0 nodes, our node will be 1, first node, the root, and it goes to the left. And if the and then we need to construct our left subtrees and right subtrees. How can we construct them? Of course, I will just mark them as preordered left and preordered right subtrees. Okay, with these names, and this will be the first part of our result, and the second part of our result will be a total number of nodes, total. And of course we need to define all this function. We need to define PL, we need to define PR, and we need to define total. So how we construct our left subtree? Of course we construct it with a preorder function. We call our preorder, but what will be the n at the left subtree? The n of the left subtree will be the same an that we get at the node, and of course we need to increase it at 1, and because we put the node at itself, and it produced +1 to the starting position of the left subtree, and we pass the left subtree here. If we go to the right subtree, we have also to define it as our preorder, but we need to take our n, add this node, count this node itself, and count the number of nodes at the left, and the number of nodes at the left we can get from PL. This is exactly the second element of the tuple. This is a total. So we need to call ascend, and we need to take second of PL. Second of PL contain the number of nodes and the left subtree, and we need this to calculate the total of which go the n which goes to the right subtree, and of course we need to pass the right subtree itself. And how can we calculate the total number of this tree? Of course it's node itself and the second element of PL and second element of PR. Okay. And this, I think this is the correct definition, but I need to take first here, because this is a tuple and we need a tree itself, and here I need to take a first from the right subtree, from the right result of preorder. Okay, should this work or not? Let's just try to compile this and load bphs. Doesn't work as always from the first start. So I'll write some parentheses, additional parentheses here, I think. Let's try to reload. Okay, it's loaded. And let's run the preorder function with our tree of this type. Let's try to run this preorder. We have 0 nodes before this start this, and you can see that we take some preordering. A is 1, B is 2, and D is 3. Yes, D is 3, and E is 4. C is 5, F is 6, G is 7, and we have total 7 nodes. And I think this is a correct order. So guys, this was a labeling of a binary tree with preorder labels. Thanks for watching. Push like button, push subscribe button, write comments. See you in the next video. Bye.